Jason, tell me what you know about mechanical seals. What are they? How do they work?
So a mechanical seal is basically a sealing assembly typically used in rotating applications. Mechanical seals consist of simply a rotating component and a stationary component, and they're used to seal different fluids and media.
So when it comes to mechanical seals, what types of fluids are we typically sealing in these applications?
Yeah, that's a great question. In the applications that we typically work on, it's a combination of fluids and media. So typically there's air on one side of the seal, and on the other side of the seal could be fuel, could be hydraulic fluid, and typically we are trying to keep those fluids separated. Usually it's a mixture of both. It could be an air-oil mist, it could be an air-fuel mist, but those are typical applications for us.
So how does the typical operation of a mechanical seal work? How do they actually work? How do they function?
So again, you've got a stationary component and a rotating component. The stationary component is typically what you would consider the seal, and that's going to have a sealing element. Typically we're using carbon, so that's going to have a seal nose, we often refer to it. And then on the other side you're going to have the rotating component, which is usually what we would call the rotor or the mating ring. The rotating component, again, often called a rotor, is riding against that seal nose. And usually there's some kind of a film of air or media in between those two. In the case of a contacting seal, those two surfaces are in contact, and there could be a little bit of fuel, oil in between there. And in the case of a liftoff seal, those faces are actually separated, and there's a film of high pressure air in between those two surfaces.
Okay. And so when you're thinking about a mechanical seal design, what are some of the key characteristics that you need to consider when you're creating that design?
Yeah, there's actually quite a few things that we have to consider when we're doing a new design. First and foremost is what we would call the PV, and that's simply a function of the pressure that the seal is going to see times the surface velocity at the seal face, and that's a function of the radius or diameter of the seal and the rotational speed. That's a really good way for us to kind of quickly evaluate the system and advise our customer as to whether or not one, a mechanical seal is appropriate, and two, the type of mechanical seal that we might spec in. The next thing that we often are having to consider is the physical space constraints. Oftentimes we have limited real estate to work with, so we have to design a package that fits in a very small space. We also need to understand what's most important to our customer. So in some cases our customer might be most concerned about leakage, and in other cases they may be looking for longer life, and there's sometimes a trade-off between those two things. We also need to consider the fluids and the media that the seal will be exposed to, and make sure that the materials that we select are compatible and going to help us kind of meet those customers' goals. So there's quite a few different parameters, and typically there's trade-offs anytime we're doing a seal design, so really understanding what the priorities are for our customer is really what drives a lot of our design decisions.
And that's a great overview of mechanical seals. I mean, you really hit a lot of the basics, and I think it'll help everybody understand that a little bit more.
Great.
Thank you.
Yeah, my pleasure.